Good morning, students. Sorry for the little delay. This time I will extend in that next class. Okay, in this session I am going to take that laws of motion. Laws of motion is nothing but Newton's laws of motion. See, momentum. Momentum is the product of mass into velocity. Momentum is the product of mass into velocity. Otherwise, we say that momentum is the quantity of motion. How effectively the body that moves is called as the momentum. When we take that two objects which have different masses have the same momentum. If the two objects of, if two objects of different masses have same momentum, the lighter body possesses greater velocity. Momentum, the formula for the momentum is, it is better to explain. The formula for the momentum is momentum P is equal to product of mass into velocity. If velocity is taken as constant, then momentum is directly proportional to mass. At velocity constant, momentum is directly proportional to mass. That means with increasing of mass, momentum increases. This is the first one. Next, when the mass is kept constant, momentum of the body is directly proportional to velocity. This is the graph. For this momentum and the velocity graph is like this. Momentum is taken along the y-axis, mass is taken along the x-axis. And the third one, if momentum is taken as constant, m into v is constant. That means m is inversely proportional to v. If mass increases, velocity that decreases. If mass decreases, velocity that decreases. See, velocity is taken here, mass is taken here. With increasing of mass, velocity of the body that decreases. These are the graphs for the momentum, relation between momentum, velocity, momentum, and mass. Next, what is that kinetic energy? Kinetic energy Ke is equal to half mv square. Kinetic energy Ke is equal to half mv square. Momentum P is equal to m into v. So I'm squaring this momentum. P square is equal to m square v square. Here also, if I take that, Ke is equal to 1 by 2 m v square into both the numerator and denominator. If I multiply with mass, I will get kinetic energy Ke is equal to half m into m square v square divided by m. Therefore, kinetic energy Ke is equal to m square v square will be equal to p square divided by 2m. This is the relation between the kinetic energy and momentum. Ke is equal to p square divided by 2m. Otherwise, p square is equal to 2m into Ke. P is equal to square root of 2m into Ke, we will write. This is the relation between the momentum and the kinetic energy. Now, they'll ask that if some x percentage of kinetic energy is increased, x percentage of kinetic energy is increased, x percent of kinetic energy is increased, then the percentage of increase in momentum. Percentage of increase in momentum, how much they'll ask it. Then direct formula, shortcut formulas also 3 or 4 are there. Out of them, very easy one and simple one I am taking that. Delta Ke2 by Ke1. Ke2 divided by Ke1 into 100. Into 100 is equal to P2 by P1 whole square minus 1 into 100. This is the formula to calculate percentage of increase in kinetic energy. Sorry, reverse I wrote. If kinetic energy is increased, if the kinetic energy is increased, then we have to calculate what is the percentage of increase in momentum. So delta P divided by P into 100 is equal to square root of KE2 by KE1 minus 1 into 100. This is for increase in momentum. This is the percentage of increase in momentum. Instead of that, if X% of momentum is increased, then the percentage of increase in kinetic energy, that what I wrote now, that is the formula. KE2 divided by KE1, KE2 divided by KE1 into 100 is equal to P2 divided by P1 whole square minus 1 into 100. Sorry, minus 1 into 100. Please note down this. This we don't get in all the books. It will be helpful while solving the numericals. Please note down this too. Otherwise, take the screenshot. Who is this? Please mute. That Shreyas. Please mute. Please take the screenshot. I'm going to erase this. Next. Okay. Then whenever we take that impulse is that product of mass into product of force into time of action. What is impulse? A large force that acts in the small interval of time, which will give the change in momentum. Impulse is that a large force that acts in the small interval of time. I is equal to F into T. Or impulse will be equal to change in momentum. I is equal to mv minus mu. Or F into T is equal to mv minus mu. From this, let us suppose they have asked a time period. T is equal to mv minus mu divided by F we will take. This is the formula to calculate impulse. What is impulse? A large force that acts in the small interval of time. In the cricket, the fielder, after catching the ball, he pulls his his hands in the backwards. After catching the ball, he pulls his hands in the backward direction. Then what happens? Time of action increases. If time of action increases, force applied will be decreased. F into T is taken as constant, then F is inversely proportional to T. If time of action increases, force applied on it will be decreased. So the fielder, after catching the ball, he pulls his hands in the backward direction. He is increasing the time of action. That's why less impact will be there on the hands of the keeper. Or when the vehicles, they are going on the uneven road, shock absorbers, they'll increase the time of action. Then less impulsive force will be there on the rider. Right? This is impulse. Then let us suppose F1 is a force that is acting on the time period T1 and F2 is the force that is acting in the time period T2. Then impulse I is equal to F1 T1 plus F2 T2. This is that impulsive force when F1 is the force that acting in T1 seconds and F2 is acting in T2 seconds, then impulse is F1 T1 plus F2 T2. Then a ball is there, a ball of mass m is there. If it hits the wall with velocity u and if it rebounds back with the same velocity, then change in momentum. Delta P is for change in momentum. Change in momentum means mu minus of minus mu we will take. So change in momentum is equal to 2mu. Momentum of the body will be m into u in this direction. In opposite direction, again momentum of the body will be there. Delta P is equal to 2mu. When the body is there, an object is there in the lift. An object is there in the lift. An object of mass is there in the lift. If the lift is moving down with uniform velocity, or if the lift is moving up with uniform velocity, in both the cases, apparent weight of the body W dash is equal to real weight mg. Apparent weight of the body will be equal to real weight. This is the first case when the body is there in the lift and the lift is moving down or moving up with constant velocity. This is that apparent weight will be equal to real weight. Instead of that, the lift is moving down with an acceleration. This is the lift and the lift is moving down with an acceleration. Therefore, apparent weight is equal to m into g minus a. When the lift is moving down with an acceleration a, then apparent weight of the body in the lift is W dash is equal to m into g minus a. This formula important. The problems are there previous in CET based on this problem, and based on this formula we solve those. So I'll explain those problems in this session. When we take this is third case. When the lift is moving up with an acceleration, apparent weight is equal. Apparent weight of the body in the lift is W dash is equal to m into g plus a. When the lift is moving up with an acceleration upwards, then apparent weight is equal to m into g plus a. Right? This is regarding that apparent weight. Okay. So let us suppose n bullets are fired from a gun. N bullets are fired from a gun, each with velocity v, and mass of each bullet is m. Then force required to hold the gun is F is equal to mnu. In the time period t seconds, if they say F is equal to mnu divided by t, we will write. In the problem, if they say per second, n bullets are fired from a gun, each bullet mass is m and each bullet velocity is taken as v, then n bullets are per second. N bullets are fired per second if they give. N bullets are fired from the per second if you take F is equal to mnu. F is equal to mnu. If n bullets are fired per second, then F is equal to mnu. Next, whenever we take this where balloon, that is total mass of the balloon is taken as capital M. Let us suppose total mass of the balloon is taken as m. This is the balloon. Total mass of the balloon is taken as capital M. As mass is more, that is descending down with an acceleration a. Then if you want to make it to send up, we have to remove certain mass from it. Mass should be detached from it to move up with uniform acceleration a. Once again, I'll repeat, a balloon of total mass along with the gas is taken as m. It is descending with an acceleration a in the downward direction. On removing certain mass from it, a mass m is removed from it, then it has to move up with an acceleration a. How much mass is to be removed? The last balloon has to move in upwards with an acceleration a. then how much mass is to be detached from it? M is equal to 2ma divided by G plus A. The mass is detached from the balloon is M is equal to 2ma divided by G plus A. 2ma divided by G plus A, right? Whenever we take that police diagrams, once it is given in CET like this, we'll check it. It is a vessel. It is a vessel. Let me explain. It's a vessel which consists of liquid in it. Liquid is there in it. Liquid is there in it. The vessel is moving towards right with the uniform velocity. Then shape of this liquid surface will be like this. This is the horizontal shape, it will be there. If the vessel is moving with an acceleration, positive acceleration, the shape of this the liquid in it will be like this. If the vessel is moving with negative acceleration, the shape of the liquid in this is taken like this. With the negative acceleration, the shape of the liquid will be like this. This is regarding it. Next, let us consider a block is placed on a horizontal surface. This is most important. Repeated problems are there from this. Okay, when a block of mass M is placed on a horizontal surface, let us suppose it is a block whose mass is taken as capital M. On this, if I apply the force F is the applied force, as a result it moves towards the right with an acceleration A. Then according to Newton's second law, F is equal to ma, then acceleration A is equal to F divided by M. Okay, instead of this, whenever we take M1 is the mass of the first block, M2 is the mass of the second block. Applied force on it is taken as F. F is equal to M1 plus M2 into A. Our acceleration A is equal to net force, means total applied force divided by total mass. F divided by M1 plus M2. F A is equal to F divided by M1 plus M2. Instead of that, in between these two, contact force is there. This contact force opposes the motion of the first block, or it helps to drive the motion of the second block. Then the contact force F is taken as M2 into A. The contact force F is taken as M2 into A. Like if I take the three blocks on the horizontal surface, when the three blocks are placed on the horizontal surface, each block consists of a mass M1, M2, M3. The blocks of masses they'll have M1, M2, M3. They are placed on the horizontal table. Then applied force on this is taken as F. F is the applied force on it. Block of the mass M1. This block mass is taken as M2. This block mass is taken as M3. M1, M2, M3 are the masses of the blocks. A for acceleration. Then in between these two, contact force F1 will be there. And in between the block, second block and third block, contact force F2 will be there. Now, whenever we take that, acceleration is equal to net force divided by net mass. F divided by M1 plus M2 plus M3. This is the acceleration of the system. Then if I want, what is the contact force F1? F1 opposes the motion of the first block, as well as it helps to drive the second block and third block. That's why contact force F1 is equal to F1 is equal to this helps to move that second block and third block. That's why F1 is equal to M2 plus M3 into A. This is that contact force between the first block and second block, right? If we take that contact force between the second block and third block, it will opposes the motion of first block and second block, but it drives the first block motion. It drives the third block. That's why contact force F2 will be equal to M3A. Contact force F3 is equal to M3 into A. This is the contact force between second block and the third block. Okay, next. I'll check that power came or not. No power, right. This is the case. Next. Instead of this, if the blocks are placed on the horizontal surface, let us suppose 3 blocks of masses M1, M2, M3 are placed on the horizontal surface. On the horizontal surface, they are pulled. They are connected with that inextensible strings. Means what? Wires. They are connected with inextensible strings. Means wires. These are connected. Then blocks masses are taken as M1, M2 and M3. Applied force is taken as F. The total system moves with an acceleration A. Then acceleration of the total system A is equal to F divided by M1 plus M2 plus M3. This is the acceleration of the system. Acceleration of system A is equal to F divided by M1 plus M2 plus M3. M3 will be there. M1 plus M2 plus M3. Then tension will be there. In the first block, tension is taken as a T1. And in the second block, tension is taken as T2. T1, T2 are the tensions. So T1 is equal to M1A. Otherwise, on substituting the value of acceleration here, we'll get tension T1 is equal to M1F divided by M1 plus M2 plus M3. Or tension T2, if we take T2 is the tension that is due to that 2 blocks. For these 2 blocks, the tension T2 is there. Therefore, T2 is equal to tension T2 is equals to M1 plus M2 into A. Then tension T2 is equal to M1 plus M2 into A means what? F divided by M1 plus M2 plus M3. T2 is equal to M1 plus M2 into F divided by M1 plus M2 plus M3. This is the case, right? Instead of that, 2 blocks are taken and they are placed on the horizontal surface. 2 blocks are taken and they are placed on the horizontal surface. Let the 2 blocks are taken as, this is the first block of mass M1 and M2. Let us suppose this is the first block of mass M1. The blocks masses I am taking like this. This is the second block of mass M2. This is the first block of mass M1. Right? Instead of connecting with that wires, it is connected with the help of the spring. These 2 are connected with the help of the spring. And this is pulled with a force F. Then acceleration won't be same, because on pulling this will extend the spring. That's why both the masses won't move with the same acceleration. It moves with an acceleration A1, it moves with an acceleration A2. A1, A2 are the accelerations. Then whenever we take these accelerations of these bodies, for the first block of mass M1, We'll take that. Applied force is F. The opposing force will be there due to the spring. Applied force minus opposing force is equal to M1A1. And for the second block of mass M2, for M2, we'll take that F is equal to M2A2. F is equal to M2A2. These are the cases. Okay. I am coming to that police concepts. Police concept is important. Before that, one more is there. Important, repeated one many times in various competitive exams, especially this CET and AAPMT. The repeated problem is there. Direct formula. They have asked it. The direct formula. What is that formula they have asked it? So it is a chain. Chain not. A rope of length L is placed. Let us suppose a rope of length L is placed. It is a rope. It's a rope of length L is there. A rope of length L is there. From one side, it is pulled with a force F. With a force F, it is pulled. Means a force applied at one end. Then they will ask, what is the tension? What is the tension at the point P, which is at a distance X? Which is at distance X from the end where the force is applied. From this end, P is at a distance X. Then what is the tension at this point they have asked? What is the tension? T for tension at this point. So important this is. Tension at this point, if you want, T is equal to F into 1 minus X divided by L. This is the formula to calculate tension at the point P when the force F is applied on the rope of length L. T is equal to F into 1 minus X divided by L. Next. When we take this, a block of mass M is placed on a horizontal surface. A block of mass M is placed on a horizontal surface. Then it is pulled with a force. Let us suppose P is the applied force. Then a block of mass M is placed on a horizontal surface. This is a block of mass capital M, which is placed on the horizontal surface, and it is pulled with a rope of mass small m. It is pulled with a rope of mass small m. Then they'll ask, what is the acceleration and what is the acceleration and what is the force exerted. So a block of mass M is there. This block of mass M is pulled with a rope of mass small m. A block of mass capital M is pulled with a block of mass small m with a force F. Then acceleration of the system, A is equal to applied force F. Instead of that F, in the previous years, what did they ask? F is the force. Instead of that force F, what did they mention? P is the force they mentioned. They have given P is the force. Therefore, acceleration A is equal to P divided by M plus M. Next, force experienced on the block they have asked it. F is equal to MP divided by M plus M. This is the force experienced on the block of mass capital M. Next, police concepts. I am coming to that. Police concepts. This is most important. General method is so lengthy. I am going for shortcut formulas. How to take that? Whenever we take a pulley, if it is connected with the same wire or same string, then same tension will be there. If the wire is connected with that same, sorry, if the bodies are connected with the same string, then tension will be same. Let us suppose this is the block of mass M1. M1 is the first block of mass M1. M1 is the first block mass. Other block I am connecting. I am connecting the other block of mass M2. Then in this acceleration, tension will be there. Tension in it is due to that second block of mass M2. Tension in the first block is due to second block of mass M2. And the tension in the second block is due to the first block of mass M1. This is same tension will be there. As M1 and M2, they are connected with the same string, tensions will be same in both of them. If M2 is greater than M1, mass of the second block is greater than mass of the first block. In such case, acceleration A is upwards, and in the second block, acceleration is in a downward direction. So if you want to calculate acceleration A is equal to net force divided by net mass. Net force means what? The block which is moving downwards, that acceleration is M2 into G. And the block which is moving upwards, its weight is taken as M1 into G. So here net force is nothing but weight of the block which is moving down. Weight of the block which is moving down minus weight of the block which is moving up. M2G minus M1G divided by net mass means M1 plus M2 we will take. Therefore, acceleration A is equal to M2 minus M1 into G divided by M1 plus M2. Acceleration A is equal to M2 minus M1 into G divided by M1 plus M2. If the first block of mass is taken as M1, second block mass is taken as M2, then acceleration of this one is A is equal to M2 minus M1 divide M1 into G divided by M1 plus M2. This is the shortcut formula. Then tension T is equal to 2M1 M2. Tension T is equal to 2M1 M2 G divided by M1 plus M2. This is the way to calculate it. Then I will take one example. Let us suppose a block of mass M1 is taken as a 5 kg and M2 is taken as a 10 kg. M1 is taken as 5 kg and M2 is taken as a 10 kg. In such case, this is 5 kg. M1 is taken as a 5 kg and M2 is taken as 10 kg. Then acceleration formula, I told you that acceleration is equal to M2 minus M1 into G divided by M1 plus M2. Then acceleration A is equal to MT is how much? 10 kg minus M1 5 kg. 10 kg minus 5 kg. 10 kg minus 5 kg divided by 10 plus 5. 10 plus 5. Acceleration A is equal to 10 minus 5 will be equal to 5 into G also there. Into G also will be there. So then 10 minus 5 will be equal to 5. 5 divided by 15 into G. This is 5 that cancel 15 3 times. Then acceleration A is equal to G divided by 3. If you want tension T is equal to what? 2m1 m2 G divided by m1 plus m2. This is the formula for the tension. Then tension T is equal to 2 into m1 is 5, m2 is 10 into G divided by G divided by M1 is taken as 5 kg, M2 is taken as 10 kg. Therefore, tension T is equal to 2 5s are 10. 10 into 10, 100. 100 divided by 15. 100 G divided by 15 we will get. This is the tension. Other methods also there. All of them we cannot discuss now. So this is that direct formula I have used. T is equal to M1 M2 G divided by M1 plus M2. This is for this pulleys problem. Instead of that, if the block is placed on the horizontal surface and it is connected with the pulley with the help, it is connected with another block with the help of a pulley. Let us suppose this is a pulley. With the help of this pulley, a block is connected. A block of mass, let us suppose this mass I am taking it as M1 is that first block mass. Then acceleration in it is taken like this. Then M2 is the second block mass as M2 is taken as M1. M2 is greater, M2 is taken as greater than M1. Then acceleration will be there in the downward direction in the second block. So if mass M2 is greater than M1, this will be like this. With the help of the pulley, these are connected. Then what is the formula for acceleration? Acceleration is equal to net force divided by net mass. What is meant by net force? Net force is nothing but the weight of the block that is moving down, M2G, minus weight of the block that is moving up. Any block that is moving up? No. This block is moving towards the left. That side. So its weight is not considered in the net weight, but its mass is considered. So weight of the block that is moving down minus weight of the block that is moving up. Second block is not moving up. This first block of mass M1 is not moving up or moving down. That's why we don't count it in the case of net force. Therefore, acceleration is equal to net force is nothing but M2G divided by net mass is M1 plus M2. Net force is taken as M2G. Net mass is taken as M1 plus M2. Therefore, this is the acceleration. If you want tension will be same in both that blocks. So tension, if you want easy way is this one. If you take that this one, F is equal to tension, if you want tension T is equal to M1 into A. This is the formula to calculate the tension. Easy method it is like this. Easy method is this. Okay. Now I am going to that previous year's problems. I am going to previous year's problems. Next, frictional force whenever we take. The frictional force is a self-adjusting force. Let us suppose a block is placed on a rough horizontal surface. on this, if the force F is applied on this block, if the force F is applied, a block on this block force F is applied, in this case applied force is F, opposing force will be there in opposite direction. That opposing force is called as the frictional force. Then frictional force that will take F is equal to mu s into mg. Frictional force F is equal to mu s into mg. Let us suppose on generally when the curved path is there, outer edge of the road will be elevated. So on the unbanked road, so power came. I'll switch on this. I'll keep it in charging. One moment. To move any body in the circular path, it needs the centripetal force. So on an unbanked road, the centripetal force is provided by the frictional force. If the banking is not there, what is meant by banking? Angle of banking. Whenever turn is there, a circular path is there. To move in circular path, the centripetal force is needed. So to move any body in the circular path, the centripetal force is needed. So generally the roads are rail tracks. They are outer edge of that track or outer edge of the road that is elevated. That's called banking of the road. If it is not banked, frictional force will provide the necessary centripetal force. Then in that case, what is the formula for the centripetal force? Centripetal force is equal to mv square divided by r. Centripetal force F is equal to mv square divided by r. And we know relation between the linear velocity and angular velocity is v is equal to r omega. In this v, if you write r omega, centripetal force is equal to m into v means what? R omega whole square divided by r. Now centripetal force is equal to mr square omega square divided by r. Both in numerator and denominator it will get cancelled. Then centripetal force is equal to mr omega square. Centripetal force is equal to mr omega square. So on an unbanked road, centripetal force is provided by the necessary centripetal force is provided by the frictional force. I'm going to start that numericals. Laws of motion, this case problems I am discussing, these are given previous years, so 2021, 2020, 2019, like that I have taken back. These I have taken in the backwards, 2020, 2021, like that, 2021, 2020, 2019, like that, 2018, like that I have taken. Okay, in this case, all these problems, a coin is placed on a rotating turnable table. A coin placed on a rotating turnable table just slips if it is placed at a distance of 4 centimeters. So a coin is placed on a turnable table. It slips just it is at 4 centimeters from the center. Let us suppose it is at 4 centimeters from the center. It will slip. Okay. whenever the angular velocity of this one is taken as omega, when a coin is placed on a rotating turnable table, it just slips if it is placed at a distance of 4 centimeters, when the angular velocity is taken as omega. And if the angular velocity of the turnable table is doubled, so in the case, what happens? Omega 1 is taken as omega. First case, omega 1 is taken as omega. Distance R1 is taken as 4 centimeters. Then what did they say? It is distance is if the angular velocity of the turnable table is doubled, it will just slips at a distance of. So if the angular velocity is doubled, then what happens? Even this is placed very near to the center also, it will fly off. Then at what distance it will fly off? At what distance it can fly off? It will slip, they have asked, from the center. At what distance? Means even if at what distance it has to fall down. If it is at 4 centimeters from the center, the object is there, then it will slip. So on increasing the angular velocity of the turnable table, if angular velocity of the table is doubled, omega 2 is equal to 2 omega. Angular velocity is doubled. Then what is R2 they have asked? As it is rotating on the turnable table, it is not banked one. So centripetal force will provided by the centripetal force will be provided by the frictional force. Centripetal force is provided by the frictional force. What is the centripetal force? Centripetal force F is equal to mr omega square. What is the frictional force? Mu s mg. From these both sides we may cancel mass. M we make it cancel. Then r omega square is equal to mu s into g. Then we need that what is R2 they have asked. R is equal to mu s into g divided by omega square. Therefore R is this is R for distance. Therefore R is inversely proportional to angular velocity omega square. It is inversely proportional to angular velocity omega square. Right. Then we'll write that R1 divided by R2 is equal to omega 2 divided by omega 1 whole square. From this, R1 is taken as 4 centimeters. R2 we need 4 by R2 is equal to omega 2 is 2 omega. Omega 1 is taken as omega. So 2 omega divided by omega whole square. Both in numerator and denominator omega gets cancelled. Therefore 4 divided by R2 is equal to 2 whole square means what? 4. 4 divided by 1. 4 and 4 they gets cancelled. Then what is there? R2 is equal to 1 centimeter. If it is placed, angular velocity is doubled, and even though it is placed at 1 centimeter from the center, it will fly off. Initially angular velocity is taken as omega, and the object is placed, a coin is object, not coin is placed. Coin is placed 4 centimeters from the center, then it will skip. It will skip. If it is placed at 1 centimeter and on increasing the angular velocity to 2 times. Therefore, even if it is placed 1 centimeter, whenever it is placed at 1 centimeter from the center, it will skip. Less than 1 centimeter distance, if you keep it, it won't skip. Next. One end of the string of length L is connected to a particle of mass small m, and the other to a small peg on a smooth horizontal table. If the particle moves in the circle with a speed v, then the net force on the particle will be. See here, it is in the vertical circular motion. This is vertical circular motion. This is at the center, from the center, a bob is, let us suppose, connected. Bob is like this. One end of the string is connected particle of mass m, a mass m like that. So it will move in the circular path, in the vertical circular path. This is, whenever it is moving in the vertical circular path, then necessary centripetal force is needed. Whenever it is moving in circular path, this is connected from the center. Whenever it is moving in the vertical circular path, the necessary centripetal force is provided by. The necessary centripetal force is provided by the tension. In this case, the required centripetal force is provided by tension. T for tension in it. Tension will be there. Necessary centripetal force is provided by the tension in the string. That's why this first option is correct. Next.
Sir, tension means force acting on the body, sir.
Tension is nothing but stiffness. It is nothing but force only. So let us suppose if I connect a body like this, one mass I have attached like this. Mass attached. In the downward direction, weight of the block will act. In the upward direction, opposing force, balancing force will be there. That balancing force is nothing but tension. So this tension acts in upward direction. Weight of this block body or weight of this particle that acts in the downward direction. So T for tension are nothing but force. Next, whenever we take what is given, one equation is given, a body with mass 5 kg is acted upon by a force of minus 3i cap plus 4j cap newtons. If its initial velocity is taken at the time period t is equal to 0, then v is velocity of the particle is given as velocity of the body is given as 6i cap minus 12j cap meters per second. Then the time at which it just have a velocity along the x-axis. So along the y-axis. So if you want velocity on the y-axis, the velocity on the x-axis will be 0. The velocity on the x-axis, where the velocity on the x-axis is 0, there velocity on the y-axis will be there. That we have to calculate. First, given data, according to given data, mass is given. Mass of the block is given as 3 kg. Mass of the block is given as 3 kg. So force acting, it is provided. F is equal to minus 3i cap plus 4j cap. Next, velocity v is equal to 6i cap minus 12j cap. Like this, the velocity is given. From this, we will write. This is ux, velocity on the x-axis, will say that. This is the ux and it is the uy. Okay, then force that is acting along the x-axis. This is the f-axis, this is fx, this is fy. Then first we need what is the velocity that is acting on the x-axis. ux is equal to 6 meters per second. ux is equal to 6 meters per second. Then the acceleration A is equal to F is equal to ma. Then acceleration A is equal to F divided by m. If the velocity is decreasing order, the acceleration is called as a negative acceleration. So then retardation, we say that A is equal to minus F divided by m. A is equal to minus F divided by m. So then acceleration that we will take along the force acting along the x-axis divided by mass. Then acceleration A is equal to minus F means what? Fx is taken as minus 3. It is taken as minus 3. Acceleration will take that. No need to take that. Magnitude we may take that. So acceleration A is taken as, we are taking magnitude only. Acceleration A is equal to F divided by m. Fx is taken as 3 divided by mass is taken as. Otherwise, here also we can take that. A is equal to minus F into x. Minus of minus 3 divided by mass is taken as 5 kg. So along the x-axis, acceleration Ax is equal to 3 divided by mass is given how much? Mass of the body is taken as 5 kg. So 3 by 5 meters per second square. Then they asked to calculate what is the velocity on the y-axis we have to calculate. So velocity on the y-axis means the time required for the velocity along x-axis to become 0. Nothing but velocity on the y-axis we have to take that to start the velocity on the y-axis. Therefore, we take that time period t is equal to velocity on the x-axis ux minus ux final velocity will be 0. Vx minus ux divided by acceleration ax we will take. Then t is equal to this is ux is 0. Final it is 0 minus ux is equal to 6 divided by a is equal to 3 by 5. That will be minus 6 into 5 divided by 3. 6 into 5 will be 30. Magnitude whenever we take that 30 divided by 3, it will be equal to 10. Therefore, time period is 10 seconds. The time period is taken as 10 seconds. Like this. This is a little bit hard problem. Other problems won't be like this. Next. A man weighing 60 kg is in a lift moving down with an acceleration of 1.8 meters per second square. The force exerted by the floor on him is So then a mass of the block is given as m is given as 60 kg. Lifting up with an acceleration, moving down with an acceleration. Acceleration A is 1.8 meters per second square. Then what is the force exerted by the floor on him? Force exerted by the floor on him is to be calculated. Then apparent weight is to be calculated. This is nothing but apparent weight. The apparent weight W dash is equal to m into g minus a. When it is moving down, lift is moving down, apparent weight is equal to m into g minus a. Therefore, apparent weight W is equal to M is given as 60 kg. 60 into acceleration due to gravity, we may take G is 9.8 meters per second square. So it will be 9.8 meters per second square. Will take 9.8. Acceleration is given 1.8 meters per second square. 1.8. Therefore, apparent weight is equal to 60 into 9.8 minus 1.8, it will be equal to 8. So apparent weight is equal to 6 8s are 48, 480, apparent weight 480 newtons. As it is the weight is nothing but force, 480 newtons. Please go through it once. Okay, next problem. Up to 8:30 only I will take. At 8:30 I will stop the class, and 15 minutes we lost the time. This we will see. I will take this extra time in the next class. So tomorrow physics class won't be there, and day after tomorrow again 7 7:10 7 or 7:15 like that. The sir will make it 7:15. Right, so day after tomorrow. Tomorrow my class won't be there. Right. A block rests on a rough inclined plane, making an angle 30 degrees with the horizontal. The coefficient of the static friction between the block and the plane is 0.8. If the frictional force on the block is 10 newtons, then the mass of the block is. According to this data, we have to draw the diagram. This is that path on the inclined plane. We'll take that inclined plane. On the inclined plane, a block of mass M is placed. So weight of this one acts in the downward direction. Weight of this one acts in the downward direction, and normal reaction is there in upwards. This is the normal reaction. In the downward direction, this normal reaction will be balanced. This is mg cos theta. This is taken as theta. Now, one component of the weight will act in the downward direction. This is mg sin theta. In opposite side, frictional force will be there. Frictional force will be in opposite side. Therefore, how much friction? What is that mass of the block they have asked? Here, frictional force will be equal to. I am seeing this. N will balance that a component. A normal reaction will balance that mg cos theta. Normal reaction balances that mg cos theta. N is equal to mg cos theta. M is equal to mg cos theta. Next, frictional force F is equal to mg sin theta. Acceleration due to gravity we will take 10 meter per second square. Then mass M is equal to F divided by g sin theta. What is the angle? It is given, theta is given as 30 degrees. Theta is given as 30 degrees. Then M is equal to F is the frictional force. So the frictional force is given as 5 newtons. Frictional force on the block is 10 newtons. Frictional force F is given as 10 newtons. Acceleration of gravity G is 10 meters per second square, they told. And coefficient of the static friction mu s is equal to 0.8. M is equal to F divided by M is equal to F divided by G sin theta. What is F? F is a frictional force that is acting, it is 10. 10 divided by G is taken as 10. 10 into sin theta means what? Sin 30. Both numerator and denominator 10 will get cancelled. That will get 1 by sin 30. That is M is equal to 1 by sin 30 means 1 by 1 by 2. It comes to numerator. Therefore, M is equal to 2 kg. Right, this is the problem. Next problem. A body of mass 50 kg is suspended using a spring balance inside the lift, which is at rest. If the lift starts falling freely under the reading of the spring balance, if it is falling freely, what about that acceleration? If the lift is falling freely, acceleration is equal to acceleration due to gravity. Then what did they ask? Then reading of the spring balance. So reading of the spring balance is equal to equal to apparent weight. Apparent weight of the body is 0 if it is moving down with an acceleration, moving down with uniform velocity. Okay, or freely falling, both will be there. Then apparent weight is equal to M into G minus A. Here for the freely falling, for a freely falling body, we'll take that acceleration A is equal to G. Therefore, apparent weight W dash is equal to W dash is equal to M into G minus A is there. Minus A is also minus G. Minus and minus they'll get cancelled. Minus G plus G get cancelled. Therefore, apparent weight is equal to 0. Next problem. Maximum acceleration of a train in which 50 kg box is lying on its floor will remain stationary if the coefficient of the static friction between the box and the train floor is 0.3. Acceleration due to gravity is 10 meters per second square. What is that given data? Mass is given as 50 kg. On floor, which remains stationary, given that coefficient of static friction between that box and the train floor is mu s is equal to 0.3. Acceleration due to gravity G is equal to 10 meters per second square. Then they asked what is the maximum acceleration? What is the maximum acceleration? So the formula for the maximum acceleration, direct formula I'm using. The maximum acceleration, I read it. The maximum acceleration. The maximum acceleration. The maximum acceleration will take that A is equal to mu s into g. Maximum acceleration A is equal to mu s into g. Therefore, A is equal to mu s is given as 0.3. 0.3 into g is taken as 10 meters per second square. Therefore, acceleration A is equal to 3 into 0.10 into 0.3 will be equal to 3 meters per second square. Like this. Next problem. A stone of mass 0.5 kg. A stone of mass 0.05 kg. Mass of the stone is given as 0.05 kg. Is thrown vertically upwards. What is the direction and magnitude of the net force acting on the stone? What is the direction and net force? So net force acting on it will be equal to weight. So direction is in downward direction. Okay, net force acting on it. Net force acting is equals to weight of the body. Weight of the stone will write. This is net weight is equal to weight acting. Net weight is equal to weight. Net force is equal to weight acting. F net is equal to M into G. M into G. F net is equal to G value. We will take 9.8 meters per second square. G is equal to 9.8 meters per second square. Then net force is equal to mass. Mass is given 0.05 into 9.8. Therefore, net force is equal to 9.8 into 0.5. 0.05. That will be equal to 0.49 newtons. This is a stone is moving up. So in that case, weight that acts in the downward direction. Okay. So this is that one problem. Then 0.49 newtons. This is the correct option. An airplane executes horizontal loop. This is the last one. An airplane executes a horizontal loop at a speed of 720 kilometers per hour with its wings banked at 45 degrees. What is the radius of the loop? Take acceleration due to gravity 10 meters per second square. Then it is given angle of banking theta is equal to 45 degrees. Radius of the loop is to be calculated. Acceleration due to gravity g is equal to 10 meter per second square. Next, velocity of this one v is equal to 720 kilometers per hour. There v is equal to 720 into 5 by 18 meters per second. There 18 that cancel in 72 4 times. 4 into 0 40. 40 into 5 it will be equal to 200 meters per second. Then angle of banking. So banking of the roads whenever you take tan theta is equal to v square divided by rg. V square divided by rg. This is a formula. Then as we want to calculate r is equal to v square divided by g tan theta, v square divided by g tan theta. Then r is equal to, what is v? V is 200 whole square. 200 whole square divided by g is taken as a 10. Clearly they have mentioned it is 10 into tan 45. Tan 45 will be equal to 1. 200 200s are 200 into 200 divided by 10 into 1. So this 1 0 get cancelled. 2 2s are 4. 4 into 1000. This is a 4000 kg. Otherwise 4 kilometers. Like this. Okay. I'm going to stop the class here. 15 minutes extra. I will take that next class. That's on the Friday class. I'll take that 15 minutes extra. Okay. Thank you. Still, I didn't share you these problems. I will share today.
Thank you.
Thank you, sir.
Um,
Thank you, sir.
Thank you.